All right, so this video is going to be a little long, so you might want to have your notes ready and also maybe some popcorn, a soda pop. All right, so for some reason, each of these steps kind of takes a little longer, but we're going to go over determinants and inverses of a matrix. First of all, let's look at what a multiplicative inverse of a matrix looks like. So let me write that. So multiplicative, that just means multiply. Multiplicative inverse matrix. So the inverse matrix for like a 2 by 2, and these are always, we're talking about square matrices in this chapter, so almost everything we have is a square matrix. Not all, I guess, but the majority of the things that we're working on are a square matrix. So this one's a 2 by 2, and an multiplicative inverse matrix looks like this. It has ones down the center with zeros in all other places. So this is a 2 by 2, but if I had a 3 by 3, it would look similar. And it would have ones down the center here and zeros everywhere else. And we also will use these, or this kind of idea, for our augmented matrix section as well. So we do see this a little bit more, but they kind of go over it as a key identity, and they say, well, A and B if A and B are square matrices, then when you times them together, you're going to get this multiplicative inverse matrix. So that's where this idea kind of helps us. So let me write that out for you. So if A and B are square, so they have to be a square matrix, matrices, then A times B and B times A has to equal one of these type of matrices that we see here. All right, and we can also call the inverse, oops, with this -1. So sometimes they say find the inverse and they write it like this. So if this was matrix A, -1, they would say that. So just know that that symbol means inverse, not to the -1 power, but actual inverse. So what we're saying here is if A and B are square matrices, A times B, B times A has to equal one of these. And then so we're going to use that idea to come up whether or not things are inverses. So we have to do matrix multiplication, which is what takes us a little bit longer to determine whether or not two things are inverses of each other. So let's look at an example. What if A is equal to 1, 2, 3, 4, and B is equal to -2, 3 halves, 1, -1 half. Are they inverses? Is A and B inverses? So there's our A, there's our B. Are they inverse? So what I do is I find A times B and then B times A, and I decide whether or not they're inverses. So let's look at A times B, and no, they're not the same. So A times B, well, they could be the same. If they both end up being this one, that's what we want. Them to both be that 1, 0, 0, 1. All right, let's times this by our -2. 1, 3 halves, -1 half. So we have to remember that matrix multiplication. So 2 by 2, 2 by 2, they can be multiplied, and the answer is a 2 by 2. So let's look at our first spot here. Our first spot would be, well, I guess I could leave room and write it out, but 1, this row times this row, and then added, right, gives us this first one. First row times the second one gives us the second one. So 1 times -2 is -2. 2 times 3 halves is 3. So that first spot is going to be negative 2 plus 3, which is 1. Yay! So far, so good. Now, next row times the next column. 1 times 1 is 1. 2 times negative 1/2 is negative 1. So 1 minus 1 is 0. Yay! So far, it's worked out the way we wanted. 3 times 4 times this column here, so row, column. 3 times negative 2 is negative 6. 4 times 3/2, well, a couple ways you can think of that. 4 times 3 is 12, divided by 2 is 6. So negative 6 plus 6 is 0. And then this last one, row, column, 3 times 1 is 3. 4 times negative 1/2 is negative 2. 3 minus 2 is 1. Yay! So A times B worked out. Now, what is B times A? Well, that's going to be negative 2, 1, 3/2. And negative 1/2, all being times by 1, 2, 3, 4. All right, so 2 times 1. 2 times 1 is negative 2. 1 times 3, let me move it up a little, is 3. So that's going to give us that first spot of 1. Yay, so far so good. And then negative 2 times 2 is negative 4. And then 1 times 4 is 4. That does give us the 0. And then 3/2 times 1 is 3/2. 3/2 times 3 is, wait, did I do that? I did that wrong. I was like, wait, no, that's wrong. 3/2 times 1 is 3/2. Negative 1/2 times 3 is 3 times the 1 is 3/2, right? So negative 3/2. So that's going to give us 0, which we wanted. And then 3/2 times 2 is 3. Negative 1/2 times 4 is negative 2, so that's going to give us the 1. So yes, they are inverses. So when it is an inverse, it probably is going to take you longer because you keep getting, numbers, zeros, and the ones in the right places. So if by chance they don't work out, then you're going to get something else, and that doesn't work out so pretty. Okay, so this does kind of take a while. You can do this on your calculator. Now, I just learned this today. I've never really taught it, and I like doing matrices all by hand. I just think the multiplication, add, subtract that you do is good for your brain to work on just those basic facts again. So I'm all for just doing it by hand. But there happens to be a matrix section on ATI 83. And the concept bites by 12, I think it's in front of 12.2 in your full textbook. It might be in your, I don't have your little paper one with me today. But anyway, you can find in there how to do this. So I'm going to hit secondhand matrix, and then it has names, math, and edit. Edit is always where you put in your matrices that you want. Math are the different things it will do for you, which is kind of cool. So the ones that we're going to use is determinant for this section, and just basic add, subtract, multiply, divide. So I'm going to go into edit. I'm going to go and I'm going to tell this to do a 2 by 2. Enter, and then I'm going to put in the numbers we had, which was 1, 2, 3, 4, and then I'm going to go back into matrix. I'm going to go into edit again, but I want to go into B, and it is a 2 by 2, but I got to make sure it has the right numbers, which it doesn't, which was negative 2, 1, 3 divided by 2 is how I'll do 3/2, and negative 1/2. All right, so I have in secondhand matrix the 2 by 2, 2 by 2 matrix. Now watch this. I'm going to go quit, secondhand quit, and go here. And then this is just our general screen. I'm going to hit secondhand matrix again, and I'm going to name A. So that puts up matrix A, times it by secondhand matrix, go down to B, enter. So I named it. I use that first row, which is name, enter. So when you multiply them, you get the 1001. Hey, pretty handy. Now I'm going to go to matrix. I'm going to name B, and I want to times it by matrix, name A, and enter. Yay, there we go. So it can multiply matrices for you. I do want you to try them by hand, but it's kind of a cool feature if you have a TI-83 or 84, or you can, if you don't, you can probably Google matrix calculator, and there's probably one on the web. Okay, so that's kind of going over inverses, determining if they're inverses. So that does take some time. Let's see. Okay, let's look at what is a determinant. Determinant. Determinant is just a number that you find that actually is helpful with different things about a matrix. So every square matrix with real number elements has a number associated with it. So that means it has a determinant. So it has to be square, and it has to have real number elements. So it has to have actual numbers in the elements. So let's look at the determinant of a 2 by 2. A, B, C, D. And the way that we find this is we kind of like cross multiply, but and then add or subtract the results. So it would go A, B, C, D. So you would go A times D, and you would subtract off B times C. And that's actually how you find that determinant. That's it. So for a 2 by 2, not so bad. Now, if the matrix happens to be bigger, like B here, it is a 3 by 3, and this is as high as we're going to go because these ones are long enough. So let's think of this as A1, A2, A3, and then same B1, B2, B3, and these would obviously be numbers in these places. So the determinant for this one, the determinant, and I'll call it DET, is going to equal, and you're going to have a first part and then subtract a second. So I'm going to use a parenthesis, and what we're going to do is we're going to do A1 times B2 times C3, right down the center here, and then add that to B1 C2 A3. So B1 C2 A3 plus the last one goes C1 A2 B3. So C1 A2 B3. That whole thing needs to be subtracted off by this whole thing, which I'm going to do in a second row because it won't really fit very well with the camera. So the next one would go A3 B2 C1. A3 B2 C1 plus, and then it's going to go B3 C2 A1, B3 C2 A1 plus C3 A2 B1. A2B1. So you can kind of see the pattern, but I have a cool way to check out and visualize this pattern. So the way that we can visualize this, because this is kind of tricky, you would have to probably have this out and be like, okay, this one times this one times this one is that number. This one times this one times that one is this number, and so forth. So it's a lot harder to get that determinant. So here's what I could do. I can take our regular matrix, and that's just A1, A2, A3, B1, B2, B3, C1, C2, C3. And I am actually going to write out A1, B1, and A2, B2, and A3, B3. So I add 2 more rows. Now watch this cool trick. I would then see the 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. These are the A1s. See? A1, B3. Okay? B1, C3. C1, 2, 3. So that's how I can get those ones. Now, I had a blue highlighter or something up here. Now the other ones go this way. Those are the ones we subtract off in blue. So 3B, 1, 2, 3, B3, CA, 1, C3, B2, B1. So I can just write out those other two rows and look, cool pattern. Much easier to do. Okay, so let's do a couple determinants. All right, so what if I have -2 and 0 and 3 and 0? What is the determinant of this square matrix? Well, the determinant says for this one times this one, so -2 times 0 minus 3 times 0. Well, 0 minus 0 is 0. So the determinant on this one is 0. That is a little bit, we'll learn also that if the determinant is 0, you don't have a inverse to that matrices. So that one doesn't have an inverse. Okay, so let's look at one that's 3 by 3 because those ones look like super fun. So 1, 0, 3, 2, 4, 6, and what did I do? 5, -1, 3. So I am going to follow this pattern right here in my blues and reds. I'm going to go, okay, now 1, 0, 2, 4, 5, -1. So I just did the first two rows again, and then it's a little easier to do my columns and rows. So I'm going to do this one first. 1 times 4 times 3. 1 times 4 is 4. 4 times 3 is 12. So I got 12. And I'm going to add that to 0 times 6 times 5. 0 times anything is 0. And then I'm going to add that to 3 times 2 is 6. 6 times -1 is -6. So there's my first one here. And then the next one will go up, right? So 5 times 4 times 3. 5 times 4 is 20. Times 3 is big. It's 60. Plus -1 times 6 times 1. Negative is -6. Plus, we just did this one, 3 times 2 times 0 is 0. All right, now 12 plus -6 is 6. Minus 60 minus 6 is 54. So 6 minus 54 is -48. Whew, not too bad, but again, it's making me add, subtract, multiply, and honestly, the more you do these basic stuff, the better you get at the harder stuff. Okay, how do I do this on a calculator? Because that's kind of tricky, right? Let's just look at the hard one, the 3 by 3 here. So I got to tilt this again till this shadow goes off. Okay, so I'm going to go secondhand matrix. I'm going to go to edit. Oops. And I'm going to go to the first one and hit enter. And I want this to now be a 3 by 3 matrix. And it keeps the numbers in there from the one before. But 1, 0, 3. 2, 4, 6 is what we just did. 5, -1. Always use the negative by the enter. -1, 3. So there, make sure, double check your matrices. Ours looks good. And then I'm going to go out and then go back into matrix and go to math, go to determinant. So I'm in the basic screen with determinant. Now I have to tell it which one under matrix, which was A, and then in the parentheses enter. -48. Hey, that's what we got. A little bit easier on the calculator, huh? All right, there is a couple, I did look up some websites. So if you Google matrix determinant calculator online, you can find some. There were a couple different options for online ones. So we can get the determinants. Okay, so the last thing is one thing that we might use the determinant for, or two things actually. So this is kind of using the determinant. So did you know the area of a triangle, using a determinant, let's say it has vertices x, 1, y1, x2, y2. Obviously these would be numbers, x3, y3. So those would be our numbers. All right, and then the area is actually going to equal 1/2 the absolute value of the determinant of the matrices, and where A, the matrix is going to look like this. 1, 2, 3, 1, 2, 3. It's going to go x1, y1, 1, x2, y2, 1, x3, y3, 1. So we actually can do our matrix just like this. We put in our values, x, y, from the 3 points, and then 1, 1, 1 on the last row, and then we find the determinant of this and times it by 1/2. Make it positive. Oops, my screen just went down. Make it positive and then times it by 1/2. So that's how you find the area using a determinant. So let's do an example of this. So what if I have the vertices 1, 3, -3, 0, and 5, 0. So how would I find the area of this triangle formed by these 3 points using a determinant? So it's kind of going to be what your directions say. Well, let's make the matrix. We would go x, y, so 1, 3, and then we know the last row is all ones, and then -3, 0, and then 5, 0. So there's our matrix. So we could do this the long way and find our determinant. I'm going to go ahead and do it the long way. So we have 1, 3, -3, 0, 5, 0. And I'm going to look down this row because there's so many zeros in here. 1 times 0 times 1 is 0. Plus 3 times 1 times 5 is 15. Plus 1 times 3 times 0 is 0. Minus, okay, 5 times 0 times 1 is 0. Plus 0 times 1 times 1 is 0, plus 1 times -3 times -3 is -9. Okay, so I have 15 minus a -9, so that's going to be a double negative or a plus, so you end up with 24. So the determinant is 24, and we know the area is half of the absolute value. Well, it's already positive, so we're good. So 1/2 times the 24 is going to equal 12. So 12 units, whatever they are, squared. Units are inches, meters, whatever they're talking about. Okay, so from here, let's see. So this is using the area. Oh, using it for the determinant, this is different than the area. If the determinant equals 0, the matrix has no inverse. Oh, if it equals 0, the matrix, let's do it this way. If it doesn't equal, the matrix has an inverse. So if it does have a 0, no inverse. If it doesn't have a 0, then it has an inverse. Okay, and then they were showing that the inverse of, let's say, A, matrix A, that's inverse, right? That's all that's saying, is equal to 1 over the determinant of A times, this is a little tricky, D negative B A negative C. So you have to change the signs of these two and switch these two. And then you times it by 1 over the determinant, and that will give you the inverse. So let's play with that a little bit. Okay, so this one's a little bit different, but this is how we can write the inverse. So let's look at an example. Did I write an example down? Yeah, here's one. Okay, let's look at an example of what I mean. So if I have 4, 2, 3, 2, and first of all, the determinant has to equal, not be 0, which it better be for this one. So 4 times 2 is 8, minus 6, 3 times 2 is 6, is going to equal 2. So this has a matrix not of 0, so hey, it has an inverse. So we know we can take 1 over 2, and we can times it by, now switch these two, so 4 and 2 are switched, and make the other two negative. So 2, -3, -2, 4. And times the 1/2 by each term, and that is your inverse. Okay, so 1/2 times 2 is 1. 1/2 times -2 is -1. 1/2 times -3 is -3/2. 1/2 times 4 is 2. How do I do that so quick? Half of anything is half of it. Think of, we say that all the time, but 1/2 times anything is half of it. Right? So there we go. So that is how we could use the determinant to find our the matrix of, or the inverse of anything. Was looking, I'm like, I should never talk and look at anything. I mess up all the time. And those are the main concepts. So I know this video is a little long, but this determinant is kind of cool idea that you can use to find your inverse of something, and then you're going to find the determinant, and then you're also going to work on the multiplicative inverse. Okay, so whether or not something has a multiplicative inverse. All right, so there you go. There's your main concepts for this section.